Hello and welcome back to this video series about the Intermediate Math League of Eastern Massachusetts. Today we're going to be starting the algebra section for Me2, so let's get right into it. So the first thing that tends to show up in Algebra Me2 a lot is sums of arithmetic sequences. And in order to find the sum of an arithmetic sequence, well, first we need to know what an arithmetic sequence is. Since an arithmetic sequence is defined as the sequence of numbers where the difference between consecutive terms is constant. So here I have three examples of arithmetic sequences. This one is 1, 3, 5, 7, 9. The next is 5, 0, -5, -10, and -15. And the last one is 121, 133, 145, 157. So if we look at our definition of arithmetic sequence, it says a sequence of numbers. Well, all of these are sequences of numbers where the difference between consecutive terms is constant. So first we need to figure out what consecutive terms are. Well, a term in a sequence is just one of the numbers. So this is a term, this is a term, this is a term, this is one, and this is one. And all of the numbers are different terms of each of these sequences. So it says consecutive terms, because we're talking about the difference between consecutive terms. So consecutive terms are terms that come, or a term that comes right after another one. So consecutive terms would be 1 and 3, because 3 comes right after 1. And then 5 and 3, because 5 comes right after 3. 7 and 5, because 7 comes right after 5. And 9 and 7, because 9 comes right after 7. So consecutive means they're right next to each other in the sequence, essentially. So it says where the difference between consecutive terms is constant. Well, the difference between 3 and 1 is 2. The difference between 5 and 3 is 2. The difference between 7 and 5 is 2, and the difference between 9 and 7 is 2. So that makes this one an arithmetic sequence. If we look at this one, the difference between 5 and 0 is 5. The difference between 0 and -5 is 5. Between -5 and -10 is 5. And between -10 and -15 is 5. And the same applies to this one. So that's what makes these arithmetic sequences. And specifically, you could say in arithmetic sequences, you add or subtract the same number after each term. So from 1 to 3, if I draw a little arrow like that, I do a +2 because I'm adding 2. And then from 3 to 5, I do also a +2. From 5 to 7, I do a +2. And from 7 to 9, I also do a +2. Oops, that's not a 2. Yeah, there we go. And from 7 to 9, I also do a +2. And in this sequence, I do the opposite. I do a -5 from each term. And I'm not going to draw them all out, but I do a -5. And then finally, in this one, I would do a +12 after each of the terms. So that's what makes all of these arithmetic sequences. So now we're going to talk about how to find the sum of arithmetic sequences. And I have this example here, 44, 52, 60, 68, 76, 84, is the arithmetic sequence that we're going to find the sum of, which means finding the sum of all the different terms in that sequence. So of course, you could add up all the different terms, 44 plus 52 plus 60 plus 68 and so on. That's a little bit redundant, so we're actually going to use a different method. And the first step of that method is to find the median. So if you don't know what the median is, essentially the median is the number that's in the middle of a sequence that's arranged numerically. So all of these sequences, since they're arithmetic sequences, are arranged numerically, which means that they just go in numerical order. So we don't actually have to worry about that. So the median is the number that's right in the middle. So I'm actually going to use this one as an example because it's a little bit easier to understand because it has an odd number of terms. So the number that's right in the middle is 5 because 5 has 2 terms to the right and 2 terms to the left, which makes 5 the most middle number in the sequence. Well, if we look at this sequence, there is no most middle number. There are 2 most middle numbers, 60 and 68, because they each have 2 terms to the right, because if you look at this group of 2 numbers, it has 2 terms to the right and 2 to the left. There's no single middle number. So when we have an odd number of numbers in an arithmetic sequence, you will have a median. That's just one of the numbers. But when there's an even number of terms in an arithmetic sequence, like this one, you're going to have 2 middle numbers. And the way that you find the median when there are 2 middle numbers is you just find the average of those 2 numbers. So the average of 60 and 68, which is the number right in between them, is 64, which means 64 is our median of this arithmetic sequence. All right, so now what you do with the median is you multiply it by the total amount of terms in this sequence. So in this sequence, I have 6 terms. So I multiply my median, which is 64, by 6, and that's going to give me the sum of all the terms in the sequence, which is 384. So your steps are to find the median of the sequence and multiply by the total amount of terms. Now, to explain why this works, because it might be a little bit easier to understand or remember this formula when you're talking about why it works. So I have this arithmetic sequence here to explain why this works. It's 1, 3, 5, 7, 9. So to understand why it works, we need to think about exactly what an arithmetic sequence means. Well, it means that the difference between terms is constant, or specifically, you add the same number from each term to the next. But what if we think about an arithmetic sequence in terms of the median? Because if we're thinking about it from adding the same number from each term to the next, we're thinking about it from the first term. You add 2, and then after the next term, you add 2, and then after the next, you add 2. What if we think about it in terms of the middle term, or the median? So the median of this arithmetic sequence is 5. So if we were to think about this arithmetic sequence in terms of the median, it would look like this. Where in the middle, we still have 5, but to the right, we have 5 plus 2. And to the left, we have 5 minus 2, which are 7 and 3 respectively. And then to the right of that, we have 5 plus 4, and all the way to the left, we have 5 minus 4, because you're adding 2 and subtracting 2 twice, and that's 9 and 1 respectively. Well, if we think about what this means in terms of how we find the sum of an arithmetic sequence, which is multiplying our median by the total amount of terms, we can actually see where it comes from. Because if I multiply my median, which is 5, by the total amount of terms, which is also 5, that gives me the sum of this arithmetic sequence as 25. And if I actually figure out what it would be if I add these all up in this form, well, what it cancels out to is 5 minus 4 and 5 plus 4 just cancel out to 5, because the minus 4 and plus 4 cancel out. And then the minus 2 and plus 2 also cancel out. So really, I'm just adding 5 times, which is why when you multiply the median by the total amount of terms, you're going to find the sum of the entire arithmetic sequence, because the entire arithmetic sequence is evenly based around the median. All right, so now I have a review question about arithmetic sequences. If you'd like to give it a try, then I'll give you a few seconds to pause the video, and then I'll explain the answer. So the correct answer to this question was 330. So the question says the sum of 3 consecutive positive numbers that are multiples of 11 is a multiple of 10. What is the sum of the smallest value of these 3 numbers? Okay, so this is a little bit more of a difficult question because we're still dealing with an arithmetic sequence here, but you don't actually get the sum as a value. It just tells you that the sum of the positive numbers that are multiples of 11 is a multiple of 10. So the arithmetic sequence that we're dealing with here is one that increases by 11 each time, because it says 3 consecutive positive numbers that are multiples of 11. So we know from the first term, which we're going to call A1, this is how we label terms. We call them A1, A2, A3, and so on. And just A1 means the first term, A2 means the second one, A3 means the third term. Anyway, so A1, A2, and A3, we know that in between them, we add 11 because they're all multiples of 11. So if we add 11 in between each term, then this is what our arithmetic sequence looks like from what we know already. So it says that the sum of these 3 numbers is a multiple of 10. Okay, so here we need to stop and we need to think about what we know about how to find the sum of an arithmetic sequence. Well, we know that if we find the median, which is going to be A2 in this case, or the most middle term, so it's going to be the second term of the sequence because it's right in the middle. So if we take our median and multiply that by the amount of terms, which we know is 3, then that's going to give us the sum. So our median, which is m, times 3 equals, and then the sum of our numbers. And it doesn't tell us what the sum is, but what it does tell us is the sum is a multiple of 10. So now what we need to think about is, since it says what is the sum of the smallest value of these three numbers, what we need to think about is what value of A2 is the smallest multiple of 10 possible that's also a multiple of 11. And I'm going to go through this a little bit, and if you don't get where I'm coming from, I promise I'll explain it. So the correct answer to this, to the value of A2, or the smallest value of A2, is 110. If I multiply that by 3, which is going to be the sum of these three numbers, that gets me 330. So the way I figured this out, and the way that I figured out that the middle number is 110, is because I know that the sum, since it's the median times some number, will be a multiple of 10 if the median's a multiple of 10, right? Because that's how multiples work. Because if I had the number 12, for example, no matter what number I multiply 12 by, the resulting number is still going to be a multiple of 12. And since 12 is a multiple of 4, if I multiply 12 by any number, the resulting number is also going to be a multiple of 4. And that same concept applies to this. If I multiply 110 by any number, the resulting number will be a multiple of 110. And since 110 is a multiple of 10, no matter what I multiply 110 by, the resulting number will also be a multiple of 10. So that's where I got the second number from. I needed to figure out the smallest number that was a multiple 11, because it specifically says that these three positive numbers are multiples of 11. I need to figure out the smallest number that was a multiple of 11 that was also a multiple of 10. And the smallest number that fit that definition was 110. So that's how I figured out what the middle number was in the smallest sum of these three numbers. And since the middle number is our median, and it's the sum of three consecutive numbers, then when I multiply 110 by 3, that's going to give me 330 as the final answer, as the smallest value of the sum of these three numbers. All right, so next we need to talk about using new equations. And from here on out, I'm going to assume that you do know the basics of algebra, which are simplifying equations with variables in them and solving for unknown variables in complex equations using the equation equality rule. So if you know how to do that, then you can just stick with this video. If you don't, I'd recommend watching my first video in the algebra section from Meet 1, where I'll explain all that stuff that you need to know that I'm about to use in this video. All right, so starting with this, it says many questions will introduce you to new equations and expect you to use them. And so here I have an example question where it says the formula to convert Celsius to Fahrenheit is F equals 9 divided by 5 times C plus 32, where C is Celsius and F is Fahrenheit. What is 95 degrees Fahrenheit in Celsius? So what this question is doing is it's introducing you to a formula that you've probably never seen before. F equals 9 divided by 5 times C plus 32. And it's asking you to use this formula to find a different value. So it says, what is 95 degrees Fahrenheit in Celsius? Well, the way that you actually do this is you just take the values that you know, put them into the equation, and simplify it like you would in any algebraic equation. So what I mean by that is, since my equation is F equals 9 divided by 5, so 9 divided by 5 times C plus 32, and I can actually simplify this to F equals 9 times C divided by 5 plus 32. So since this is my formula, so I forgot the equal sign, I can just put 95 degrees Fahrenheit into my equation because I'm calculating for Celsius. It says, what is 95 degrees Fahrenheit in Celsius? So if I put 95 in where Fahrenheit is, because that's a logical thing to do, well, now all I have to do is solve for C, because now I have an equation where I have one unknown variable. And since we know how to solve for that using the equation equality rule, we just have to solve for C. So my equation is 95 equals 9 times C over 5 plus 32. So first I need to get all the variables to one side and all the constants to the other side. So I need to subtract 32 because that's the opposite operation of addition. So if I subtract 32, on the left-hand side, that gives me 63. And on the right-hand side, I just have 9 times C divided by 5. And I'm going to move up here, up to the right, just because I'm running out of room. So now since I have 63 equals 9 times c divided by 5, I have all my variables on one side of the equation. And now what I need to do is get it so it's just variable equals some number. I don't want to know the value of 9/5 of c. I want to know the value of just 1 of c. So therefore, I need to get this divided by 5 and times 9 out. So next, what I need to do is I need to multiply by 5 since I'm dividing by 5 to get the dividing by 5 out. So if I multiply 63 by 5, and then that's going to be equal to 9 times c times 5 divided by 5. And remember, I have to do the same thing to both sides of the equation. So here I have 9 times c times 5. Well, the times 5 and divided by 5 cancel out. And 63 times 5 equals 315. And that's going to be equal to 9 times c. And then lastly, what I need to do is I need to divide both sides by 9. Since I've multiplied by 9, I do the opposite operation to get the times 9 out. And if I divide both sides by 9, then c equals 35. So 35 degrees Celsius equals 95 degrees Fahrenheit. And more specifically, what the question is asking, 95 degrees Fahrenheit is 35 degrees in Celsius. All right, and last thing in this lesson, I have a review question about using new equations. If you'd like to try it, I'll give you a few seconds to pause the video, and then I'll explain the answer. So the correct answer to this question was 98 pi centimeters cubed. Now, in an actual IMLEM question, you wouldn't have to include the unit of measurement, which is centimeters cubed. So you could have just written 98 pi and you'd also have the correct answer. So the question reads, the formula for the total surface area, which is TSA of a cone, is TSA equals pi r squared plus pi times r times h, with radius r and height h. So the radius is r and the height is h. The formula for the total volume V of a cone is V equals pi r squared times h divided by 3. Find the volume of a cone in terms of pi with a radius of 7 centimeters and a TSA of 91 pi centimeters squared. Okay, so this question is really difficult when you first read it, because it's pretty difficult to actually figure out what you need and what you need to do in order to find the answer. So let's go through it step by step and figure out what it's asking of us. So it says, find the volume of a cone in terms of pi. That's the first thing that it's saying. So it wants the volume of a cone in terms of pi. And what in terms of pi means is that you don't have, so pi is a variable that is that equals about 3.14. But in terms of pi means you don't have to multiply by 3.14. You can just represent your answer in pi's. So I have 98 pi's when I actually find the correct answer. So it says find the volume of a cone. Well, in order to find the volume of a cone, and it gives us this formula for the volume of a cone, I need to know pi, which I already know that since I'm expressing my answer in terms of pi, I can just leave that be. All right, what else do I need to know? Well, I need to know r squared, or specifically r, and I need to know h. Okay, so I need to find r and I need to find h in order to find the volume of a cone. Okay, well, it says with a radius of 7 centimeters in the last sentence. So the radius of this cone, or the r, is 7. So now that I know the radius, all I need to find is the h, or what the height is, in order to find the volume. But it never tells us what the height is in this question, which means that I probably need to calculate what the height is first, and then put it into this equation. Well, how can I calculate the height of this cone? Well, what it also tells us is that the total surface area is 91 pi centimeters squared. Okay, well, since I know the total surface area is 91 pi centimeters squared, and TSA equals pi r squared plus pi times r times h, well, I know all the variables in this TSA equation except for h, which means I can plug those variables in and then use my basic algebra just to solve for the value of h. Okay, so let's do that and figure out exactly what the total surface area is. Or sorry, not what the total surface area is, what h is using the total surface area. So if I write out my equation, which is TSA, total surface area, equals pi r8, or r squared, plus pi rh, Well, I can put in the value of my radius, which is 7 centimeters, and then I can put in the value of my TSA, which is 91 pi centimeters squared, and then figure out what h is. So let's do that. So substitute in 91 pi, and that's equal to pi times r squared plus pi times rh. And then r is 7. So I actually made a mistake. I meant to write r in as 7 in this equation. So let me erase this side and rewrite it. So 91 pi equals pi times 7 squared. I'll put that in parentheses. Plus pi times 7 times h. Okay, so now I have an equation where I can actually solve for h. And before I do that, I need to simplify this equation. So 91 pi equals, and then if I simplify this, since 7 squared is 49, then I can simplify this section to 49 pi. So if I write 49 pi, and then add that to pi times 7 times h, which is 7 pi h. All right, so now what I need to do is I need to get h on the side all on its own, or the term with h, or whatever I'm multiplying by h, which is this, on its own side of the equation. And I need to get all the other variables on the other side, which means I need to get rid of this 49 pi. And the way that I do that is I need to subtract 49 pi from both sides of the equation. Because this is a positive 49 pi, I subtract 49 pi to get rid of it. So if I subtract 49 pi from both sides of the equation, on the right-hand side of the equation, which is this side, it just leaves me with 7 pi h. And on the left-hand side, it leaves me with 42 pi. Right, and I know this is probably a little bit confusing since I still have pi everywhere in this equation. Remember, we're just expressing our answer in terms of pi, which means we don't actually need to substitute the value of pi into the equation in order to solve. In fact, in this equation, I could have done this earlier, but I'm going to do it now. Pi actually cancels out. Since you're multiplying both sides by pi, you're multiplying both sides by the same number, and it's actually useless in this equation. So technically, you could write this equation as 42 equals 7 times h. And you could solve for h as the exact same as if it is just 42 pi times 7 pi h. Pi cancels out because it's in both sides of the equation, and you're multiplying it by both sides of the equation. All right, so if I rewrite my equation, 42 equals 7h. Well, now I have a really simple problem where I just have to divide by 7 since I'm multiplying h by 7. So if I divide both sides of this equation by 7, divide this one, then I get 6 equals h, where 6 is the height of this cone. Okay, so now that I know 6 is the height of this cone, I know what my radius is already, right? It's 7 centimeters. 6 centimeters is my height, and I only need to know my radius and my height in order to find volume because I'm expressing it in terms of pi. So now I have to use this height and just substitute it into my volume equation in order to solve for the volume. Okay, well this is a little bit easier because my volume is already v equals this and this and this. So if I write my equation, v equals pi times r squared times h over 3. And then next, I substitute in my values of h and r into the equation. Then I get v equals pi times 7 squared, which I'll put in parentheses, and then times 6, which is h over 3. And then when I simplify my equation from here, I get v equals 49 pi, because 7 squared is 49, times 2, because 6 divided by 3 is 2. And then 49 pi times 2 is 98 pi. Oops, 98 pi. So 98 pi is my volume. And remember, as I said, 98 pi is my volume, and you don't have to write centimeters cubed for IMLEM questions. All right, now just to quickly review what we've learned this lesson. First, we talked about the sum of arithmetic sequences and learned that an arithmetic sequence is a sequence of numbers where the difference between consecutive terms is constant. So these were examples of arithmetic sequences where the difference between consecutive terms, and the first one is 2, the second one is -5, and the third one is 12. Then we also talked about how to find the sum of an arithmetic sequence using this one as an example. First, you have to find the median, and then you have to multiply the median by the total amount of terms, which in this case was 6, and the sum of this arithmetic sequence was 384. And then finally, we talked about why this actually works, where if we think about an arithmetic sequence in terms of the median, we see that when we add all the values in this arithmetic sequence, it just cancels out to the median multiplied by the total amount of terms, which is exactly how we found it in the first place. Then we also continued talking about the sum of arithmetic sequences by using the sum and using the total amount of terms in order to find the value of specific terms. So in this example, we knew that the sum of 5 consecutive multiples of 7 was 175. So we used this information to figure out that the median would be 175, which is the sum, divided by the total amount of terms, which is 5. So the median of this arithmetic sequence is 35, and then we used that to figure out what the other terms were and solve the question. And then we did a review question relating to the sum of consecutive terms and arithmetic sequences. And we figured out that the answer to this question was 330. And then after that, we talked about using new equations, which is when a question will introduce you to a formula that you've never seen before and ask you to use it in a question. And we learned that all you have to do is plug in the values that you already know and solve for the ones that you need in order to solve the question. So in this example, you plug in 95 for F because you have 95 degrees Fahrenheit, and then solve using basic algebra to convert it into Celsius. And then finally, we did a review question, which was a little bit difficult, where we had to find the volume of a cone when we knew the total surface area and the radius. And we used the total surface area equation to find the height, and then we used that height and radius in our volume formula to figure out that the volume was 98 pi centimeters cubed. All right, so that's all I have for today's lesson. I'm sorry that is probably a difficult one, but I hope that this helped. I'll see you next time.